Chapter 8, practice test. Page 588. Refer to the line shown below and state what each of the following describes. What do we have here? A line, WXYZ? W, X, Y, Z, and line segment WY, that would be here, wouldn't it? And line segment XZ, that would be here, wouldn't it? And where do they intersect? And what would be the answer? Where do they intersect? Where do they intersect? What?
At X and Y.
At line segment XY. Okay? So, can you work all of those, or do you want to work another one? C, line segment WX. Line segment WX. And what else? What's the other one say? Ray XZ. Isn't that what it says? Did I read it right? Because see that little arrow on the end of it? Gotta look carefully. And then what does it say? What does it mean to union those two? What would be the union of those two?
WZ Ray.
WZ Ray. Excellent. Everybody see that?
Mm-hmm.
Good. Skip 2. Number 3. How many degrees does the hour hand of a clock turn in the following times? From noon, that would be straight up and down, right? To what? 4 o'clock? Here's 3, here's 6, here's 4, here's 5. How many degrees would that be? Well, what would it be to here? What would that be? 90 degrees? And what would this be? 90 degrees? And if there's 3 segments here, that would make each of them what? 30? So what would, too many things in my hand at once here. So what would that be? 90 and 30 would be 120 degrees, right? All right. Do we need to do another nose? Maybe. 3 to 5. Here's 3. Here's 6. Here's 4. Here's 5. What would that be? Based on what we did over there.
60.
Yeah, that'd be 60 degrees. You guys are on your way. If angle A and angle B are supplementary, what does supplementary mean?
Let's look at my notes.
What?
Looking at my notes.
Good. Bring notes with you to take the test. What does supplementary mean?
Supplement of an angle is what will make it equal 180 degrees.
So that means 180. Here's angle A, here's angle B. You with me?
Mm-hmm.
The two have to add up to 180. So And the measure of A is 3 times the measure of B, so I just labeled them wrong. This is B, and this is A, and A is 3 times B. The measure of angle A is 3 times the measure of angle B. You got that?
Mm-hmm.
So, what do they want to know? Find the measure of the two angles. So, what is this one and what is this one? Well, if B is x degrees, then what would A be?
-x.
How many? If it's 3 times that, what would it be? 3x degrees. Or maybe make this a D. If B is D degrees, then A would be 3D degrees. Agreed? And D degrees plus 3D degrees would add up to what?
180.
180. So 1 of these and 3 of these would be 4 of these. So D would equal
45.
45. So B is 45 degrees, and what's A? 3 times that?
135.
135. And do those add up to 180?
Yep.
Then we got it right. Number 5. What's number 5 look like? Looks like a mess. Well, that's why you want to draw pictures of these things. Here's a line, here's a parallel line, and here's a transversal. You understand? When I start drawing this stuff, then it starts making sense to me. And I don't necessarily need to put all the letters in there, but I do want to put this little 50 in here, don't I? That little angle measures 50 degrees. Now, look at this picture. If this is 50, what do you think this one is?
50.
50. What do you think this one is?
130.
130. Everybody see why? See what's going on? So what do you think this one is?
50.
50. And what's this one?
130.
130. And what's this one?
50.
And what's this one? Does that make sense to everybody? Now let's look at the question. What's the measure of angle C?
130.
See what happens? See how I draw my picture and I kind of forget about all those letters and just put the measures of the angles in there, and it's just, and then go, oh, so C is, look at my picture, 130, and then what's E?
50.
50. And what's D?
130.
Well, there you go. It's kind of like you're looking past the forest and just getting the trees there and lining them up. Number 6, in triangle ABC, so I better draw a triangle. You see how it helps to, on your paper, to draw part of the pictures? It just kind of helps your mind sort things out. It says in triangle ABC, A, B, C. What does it say? The measure of angle A is 38, so this is 38 degrees, And what else? And B is 43 degrees. And what's next? Find C.
Bless you. Thank you.
What?
Nothing.
I sneezed.
I see.
I
She
sneezed. And she said, bless you.
Oh, so what do you do to find out what this would be?
You add up those two and then subtract the sum from 180.
Because the three angles of a triangle always add up to 180.
Mm-hmm.
So everybody have that one?
99.
Now, if you don't remember what Celeste just said, you need to write that down in your notes. 6B. Uh-oh, now they changed it. Let's see how they changed it here. The measure of A equals the measure of B equals 2 times the measure of C. So A and B are equal, right?
Mm-hmm.
And they are how much of C?
2 times.
So if this is X degrees, then that would make this one what? 2X degrees? And this one would also be 2X degrees. Agreed?
Mm-hmm.
So now what am I going to put down here that'll add up to 180?
X plus X.
2X plus 2X plus X. And that would be 2, 4, 5X is 180. So X would be
36.
36. So this is 36 degrees. So what does that make these two? If they're
2 times 30.
2 times X. 72 degrees and 72 degrees. Does that add up to 180?
Mm-hmm.
144 and 36. So I'm just checking to make sure I got it right. Number 7. Skip it. Number 8. Triangle ABC and XYZ are similar. You know what that means, don't you? When it says they're similar, here's ABC, and here's XYZ. You know what similar means?
They're the same, but one is bigger.
They're the same shape, but one is bigger. They're similar. And the measure of A equals the measure of X. So I've got those, B and Y and C and Z. So I've got the parts labeled. AC, AB is 2. Isn't that what they said? And what else did they tell us? BC is 3. BC is 3. And AC is 4. Did I copy down the information right? See how when you just go from all that verbiage to a picture, it starts to make sense. And XY is 3. Okay. Find YZ and XZ. Well, how in the world do I do that? What do you know about similar triangles?
They're proportional.
Do you have that in your notes?
They're proportional.
The corresponding sides are proportional. Now, do you know what that means? Corresponding sides are proportional. So here's 2 and 3, those are corresponding sides, and 4 and question mark. So where's my proportion? 2 over what? 3 equals 2 over 3 equals 4 over question mark. Now, could I have done this? Could I have said 2 over 4 equals 3 over question mark?
Yes.
Let's check it out. 2 times question mark, 3 times 4 is 12, so that would make this 6, wouldn't it? 2 times question mark, 3 times 4 is 12, that would make this 6.
Yes.
But because sometimes, like Celeste said this one, okay? And then when I wrote this one, she's looking at me like, what? But sometimes, some students will see this one easier than they'll see this one. And you just have to kind of accommodate the different ways of thinking that people have. So we know this one's 6. Now how are we going to find this one? I'll erase all this stuff so we don't have so much stuff in our face. And what would we do now? What's the proportion this time?
2 over 3.
2 over 3 equals
3 over x.
this 2 over this 3 equals this 3 over question mark. Agreed? So 3 times 3 is 9. 2 times question mark would have to be 4.5. So this is 4.5. And this is 6. Wasn't that fun? Number 9. What's the measure of one of the interior angles of a regular polygon with 9 sides? So, can I draw a polygon with 9 sides? Probably not. A regular polygon with 9 sides means that all 9 of them, 1, 2, 3, 4, 5, 6, 7, 8, 9. It means they're all equal and all the angles are equal. So maybe, is that right? 1, 2, 3, 4, 5, 6, 9. I got 9 angles and all the line segments are the same. And maybe when you're teaching this to little kids, you probably maybe ought to have some cutouts where you just hold it up and show them that that's what it looks like. But how in the world am I going to find the measure of one of these angles? Do any of you know this formula for the sum of the measures of the angles of a polygon? You don't?
This equals this side for the x minus 2.
Say that again.
X minus 2 times 180. So
N
x equals
minus 2 times what?
180.
180. Where does that come from? Well, think of a triangle. What do the 3 angles add up to? 180. So the sum of the angles is N, 1, 2, 3, minus 2 times 180. Think of a square. 1, 2, 3, 4. And what would that be? 90, 90, 90, 90, 360. So that would be the sum of the angles is 4 minus 2 times 180. Is that cool? Now, what do you need to have in your notes for the test? You don't need these two pictures, you just need this formula. But when Carissa said the formula, I got the impression that she had the formula down, she just wasn't sure she liked it. So I did a couple of these things here to help see why the formula makes sense. Then it's easier to accept it in my heart of hearts and work with it. So how many angles do we have here? So n is 9, right? So what's 9 minus 2?
7.
What's 7 times 180? 0. 1,260? And that's the sum of all 9 angles. So what would one angle be?
140.
Well, look at that. So one of these angles is 140 degrees. And now you would know how to draw one. Get your protractor out on a piece of paper and say, okay, I'm going to make the length of the side 4 inches long, and then I make a line 4 inches, then I measure over 140 and make another 4-inch line. You follow what's going on? You could then, now you know what each angle measures, you could draw one on a piece of paper and cut it out for your little kids to see when you're teaching it. What about 10 sides? What if it had 10? If it has 10 sides, it has 10 angles, right? So S equals what? 10 minus 2 times 180. That would be 8. What's 8 times 180? 0. 1440, and that's the sum. So what would it be for each of the angles? Divide that by what? 10, because there are 10 sides. And that would be 144. So it has 9 sides, it's 140 degrees. If it has 10 sides, it's 144. That's a pretty cool formula, isn't it? Probably want to write that in your notes, don't you? Because you're not going to keep it in your head. Bring it to class with you on Thursday when you take the test. Number 10, a rectangular plot of ground. So I just read far enough to draw a picture. Of a rectangle. And what's it say about it? Is enclosed with 120 yards of fence. So that means the perimeter is 120 yards. Is that what that means? All the way around? And the plot is twice as long as it is wide. So if this is the width, what's the length?
2 times.
2 times W? So this is W, this is W, this is 2W, and this is 2W. So what's all the way around it going to add up to be? W plus 2W plus W plus 2W equals 120. 1, 3, 4, 5, 6. 6 W is 120. So W would be 20. So this is 20. So what's the length?
40.
40. Is that what they want to know?
Yep.
Well, good for us. And if you want to check it, 20 plus 40 is 60, plus the other 60 is 120 yards. Number 11. The center of a circle is also the center of a square of side 2. Okay. So now I have a square. And each side is 2. Agreed?
Mm-hmm.
What's it say next? The center is right there. The circle passes through what? So I'm going to put these 2's in here. Because where does the circle go?
Do the vertices.
So I have a circle that goes around like this. Everybody follow that? And there's the center of my circle. You got the picture?
Mm-hmm.
Now what am I supposed to do? Find the circumference of the circle. Circumference equals what? Pi times diameter.
Mm-hmm.
So where's the diameter of that circle?
So it'd just be 2, right?
What?
Oh, 2 times pi. I mean, yeah.
See this line I drew for the diameter?
Mm-hmm.
What is that? Maybe it's too confusing, too much together. I've got a
Oh, that's not
2 by 2 by something, right?
Oh.
And that's the hypotenuse, thanks to old Pythagoras.
2.
Good old Pythagoras.
So what do we put down here? 2 squared plus 2 squared equals the diagonal squared. See why I'm calling it the diagonal?
Mm-hmm.
Or the diameter squared. So 2 squared is 4. 4. So 8 is d squared. So d would be the square root of 8. So now this diagonal is the square root of 8. And what's the circumference? Pi times the diameter times the square root of 8. So the circumference is the square root of 8 times pi. Is that the answer that it shows over on the next page? No.
It has it factored out, like.
Because they simplified it. Remember from last semester? No, Celeste says, or no, Charissa says, I didn't take your class last semester. Well, so this is 8 is 4 times 2. The square root of 4, the square root of 2. What's the square root of 4? So it's 2 times 2 times the square root of pi.
Okay.
So what happens is you just pull out the perfect square. It's called simplifying, or it's like reducing fractions. It's simplifying radicals. Number 12. If you rolled up an 8.5 by 11 sheet of paper into the largest possible cylinder that's 8.5 high. Okay. If it's 8.5 high, then I have a sheet of paper that's 8.5 by 11, and I roll it up like this. Right? And that's shaded, you can't see it. And this is the 8.5, and the circumference of the circumference of this circle is 11. You follow me? But how do I find circumference? Pi times the diameter. So the diameter times pi equals what? 11 is pi times the diameter. So the diameter would equal 11 divided by pi. Do they want you to leave it like that or approximate it?
Oh, it says leave it in common.
Is that what it shows in the answer? 11 divided by pi?
Yeah.
And if they said simplify it using 3.14, what would you do?
Pull out your calculator.
Get your calculator and divide 11 by 3.14, and that would be the diameter.
Wait, how do you know what the diameter is? I don't get how.
Okay, diameter, doesn't diameter always equal, diameter times pi always equals the circumference?
Oh, I see what you mean. Okay.
So I have to use that formula for circumference. Because this 11 becomes the circumference of my circle.
Mm-hmm.
Write yourself a note to remember that when it comes test time, because there'll be one just like this on the test. Number 13. In problem 11, oh man, why did I erase that? Find the area of the region that's inside the circle and outside the square.
You didn't erase it.
You didn't erase it.
Oh, I didn't
It's still
erase it.
there. Now you
Good.
Almost did.
So, there it is. So what's the area? What'd they say? Inside the circle? Right?
Uh-huh.
And outside the square? Well, what's the area of the circle? Area is what? Pi times what squared? The radius? Okay, what was the diameter? 2 times the square root of 2 times pi? No, the diameter was 2 times the square root of 2, wasn't it? Remember the square root of 8
Mm-hmm.
came out to be 2?
Yeah.
So the radius is half of the diameter.
Well, the diameter is 2 times the square root of 2 times pi. Right?
Because we simplified it.
Because we simplified.
So
But it's times pi.
what did we do for problem 10?
10.
It's 11.
11. Okay, we found the circumference. What's the
Oh.
circumference of the circle? 2
Oh, I
times
see
the
what
square
you
root of
mean.
2 times pi.
Okay. I see.
And this is the diameter, so half of that would be the radius. So what's half of that?
Square
What's 2 times the square root of 2 times 1/2?
root. Wouldn't it just be the square root of 2?
It would just be the square root of 2, wouldn't it?
Mm-hmm.
So the square root of 2 squared times pi equals the area. What's the square root of 2 squared?
2.
So this area here, this whole area is 2 pi. Agreed?
Mm-hmm.
But I don't want the whole area. I want to subtract what?
The area of this.
The area of the square. What's the area of the square?
4.
Or
4. So I want to subtract 4. So so this area right here, these 4 areas right here will be 2 pi minus 4. Is that cool? Is that fun?
I'm invigorated.
Fun wasn't the word that came to mind.
It was fun watching you do it. Doing it myself might be a different story.
So what's going to mess you up when you do it yourself? You say, okay, I get the area of the circle, then I have to subtract the area of the square. They'll just have different numbers in there that have you doing the same thing. So write yourself some notes so you can keep that straight. Number 14, a window in the shape of a rectangle. I can draw one of those. Is surmounted by what?
A semicircle.
A semicircle. Well, that's a cute little doorway or a cute little window.
It is.
And this is what? 3, did it say?
Mm-hmm.
And the rectangle is 4 feet tall. See what happens when you draw a picture and put the numbers on it? It just starts making sense, doesn't it? Find the total area. Total area would be all of this plus all of this. Agreed?
Mm-hmm.
Okay. Oh, what's this area here?
12.
12. We got that one, right? Now, what's this area here?
Wouldn't it just be pi?
Well, it's what? Half of a circle.
Right.
And what's the area of a circle?
Pi r squared.
The area of a circle is pi r squared, and I want half of that. So,
3.
what's the area of the circle? Pi times what number squared?
1.5.
1.5, because that's the radius. The diameter is 3, the radius is 1.5. Everybody see that?
Mm-hmm.
You got that?
Mm-hmm.
Yeah, I'm just saying this is like the long way around. It's like already 3. Just saying.
The r squared is gonna be different.
Oh, pi r squared.
Yeah. So you have to.
I need the radius, and that's 1.5.
Makes it difficult.
Because I'd use 3 for a circumference, wouldn't I?
Right.
Yeah, so I need the radius. So what's 1.5 squared? What's 1.5 times 1.5? What?
2.25.
So I get 2.25 pi is the area of the circle. And I want how much of it?
A half of it.
So divide that by 2. And what do you get? One point 125. Agreed?
Wait.
So what do you do with these two areas to get the total area?
How does that work with pi?
Oh, wow, I
'Cause
can't believe
pi
that.
is in here.
So I take 1.125 times what? Do they want me to simplify it or leave it in terms of pi? It doesn't say. Well, if we leave it in terms of pi, it's going to be 1.25 times pi, right? So that would be 12 plus 1.125 pi.
Mm-hmm.
If we took 3.14 for pi and took that times 1.125, what'd you get?
3, 5,
What'd you get?
3.53.
3.53.
5.3.
And then we add 12 to that, and that gives us 15.53. Which answer do they show on the next page? 12 plus 1.125 pi or 15.53?
They give both.
They show both? So you'll know how to do both answers, right?
Mm-hmm.
A circle of diameter 2. All right. So now I'm back drawing circles again. A circle with a diameter of 2. Number 15 has its center at the center of a square of side 2. What?
So the circle is inside the square perfectly. Right?
If the square has a side of 2, then that would be what? 2
It's just a
by
circle
2
with corners.
by 2 by 2. Everybody agree? 2 by 2. So that means the circle's inside the square. And for the other problem, what? The square was inside the circle.
That guy.
So now we've got the picture. What's the area of the region inside the square and outside the circle? They want to know this region here. Well, what would that be? That would just be the area of the square area, which is what? 4, 2 times 2, minus what? The circle area. What's the circle area? The area of a circle
2 times
is what? Pi r squared. What's the radius?
1.
1. So the area of the circle is 1 squared times pi. Or that would just be pi, wouldn't it? So 4 minus pi would be the area of the green region. What do you think?
Is that what they want us to say?
What'll mess you up with that one is drawing your picture. Making sure that if the radius of the diameter is 2 and the sides are 2, then the square has to be on the outside of the circle, doesn't it? Number 16. A rectangle is 84 long and 13 wide. I can draw that. Now do you realize what they told you when they told you in English class? A picture is worth 1,000 words. A rectangle is what? 84 by
feet long.
13. Is that what they said?
Yes.
And what do they want me to find?
Diagonal.
That would be from corner to corner, wouldn't it? Let's see, 13 and 84. That looks like old what?
Right.
Pythagoras. And see what happens? Sometimes when you're looking at it here, you don't see it. So I pull the triangle off and go, and what's Pythagoras tell us? 13 squared plus 84 squared equals the diagonal squared. What's 13 squared?
169.
What's 84 squared?
7,056.
7056. Add those together and what do I get?
7,225.
7,225, and that equals d squared. So d would be the square root of that number.
85.
35.
85.
What?
85.
85?
Yep.
How cool that it came out even.
That is really nice.
Pretty cool, huh? Is that the answer?
Oh, let's check.
So you need to bring a calculator with you that does square roots, don't you? Does your telephone do square roots?
Mm-hmm.
Okay, some telephones
Turn it sideways.
don't do square roots. You know how to make your telephone go to the place to do square roots. Yeah, figure this stuff out. That's right, figure this stuff out. Modern technology. Number 17. Find the total surface area of a rectangular box whose base is 3 feet wide and 5 feet long. All right, what do I have here? A rectangular box. The base is 3 feet wide and 5 feet long. This is 3 and this is 5. And I just draw another one up here. 3 and 5.
Ooh, the box.
box. Not a box yet, but it will be when I'm finished. Did I get it? Here's the front. You can't see this line back here, right? And you can't see this line here. You can't see this line. Don't you like it when you take your finger and just erase those little areas?
A few seconds ago, I was trying
Yeah.
to do that on my page, and it wasn't working.
Wait a second.
You see, I just pick what's going to be the part I can see, and then the rest of it I make them dotted lines. And it's, okay, now the 3 is here, right? That's the base. The 3. Now what's the height?
2.
2?
Yep.
So it's 5 by 3 by 2. You got it down?
This is surface area.
And they want to know the total surface area.
Times all these 3 added.
Okay, now think about this. What do I have for a total surface area? I got a rectangle for the top. I got a rectangle for the bottom.
Okay.
Agreed?
Wait, no.
And I have a rectangle for the front
Absolutely plus.
and a rectangle for the back. You follow me?
Uh-huh.
Here's the top. Here's the bottom. Here's the front. Here's the back. And then I have what? 2 ends. Does that take care of the total surface area? The 2 ends, the top and bottom, front and back. Now, what are the dimensions of the top?
X.
3 by 5. And the bottom? 3 by 5. So that means this is 15. Agreed? And this is 15. What are the dimensions for the front? What are the dimensions for the front? 5 by 2. And the back? 5 by 2. So that's 10. And that's 10. And what are the dimensions for the ends? 3 by 2. 3 by 2, so that's 6. And that's 6. So the total surface area is 30, 40, 50, 62. Is that what the answer says?
Yep.
That's what I got.
That's what we got.
Does that make sense to draw all those little pictures? To
Yeah.
take the box and...
But
I
we
kinda
also
like
have
the
a formula for it.
Oh, you do?
Yeah. That's a little
So,
bit easier.
bring your formula with you. I just like to figure things out. I just like to draw pictures. Okay. Number 18. The triangle shown at the right is the base of a pyramid. All right, they're going to get a little messy here. Of course, that was a little messy too. But see, sometimes, do you get the point that sometimes I'm doing things that I'm trying to model what you might want to do when you're teaching math to little kids? So I'm not being demeaning, I'm just trying to teach you some teaching methods for little, helping make sense out of this to little kids. So here's this triangle. And what does it say? What's it say about it? It's 5 by 3. And the height is what?
No, the height is 3. The other length is 5.
5 by 5. It's 5. You got to copy stuff down right, don't you? And this is the base of a pyramid. So I'm going to put the point of the pyramid up there. Maybe I'll move it over here. See what this does. zip, zip, and zip. And you can't see this part, or this part, or this part. You see that? How I sketched my little pyramid here? So now I got a picture of what I want to work with. What's the volume? Find the volume. What's the formula for the volume of a pyramid?
1/3 times base times height.
Times the capital B times the height. And B is what? The area of the base. And if the base is a triangle, what's the area of that triangle?
Is that the formula for a volume of a triangle or a pyramid or?
Uh-huh.
Yeah, okay.
What's the area of this triangle? That's 5 feet by 3 feet.
1/2 base times 3.
1/2 base times height. Right? The height of the triangle. So that would be 7.5. So the base is 7.5. So we have 1/3 times 7.5. Now we just need to find the height.
Well, we already have the height, right?
No, that's the height of the bottom triangle.
But we have the height of the pyramid. It says right here it's 4 foot high.
Oh, yeah, we do.
Oh, so it says this pyramid from here to here is 4 feet, doesn't it?
Mm-hmm.
So they've already told us that. So we put 4 in here, and what do we get? 1/3 of 7.5 is 2.5 times 4. So the volume of the pyramid is
10.
10. Is that what the answer book says?
Yep.
It does?
Yep.
Boy, that came out too easy, didn't it? Number 19. So what's going to give you trouble with this one?
The volume of the cone.
You need to write some formulas down. Write some steps on what do you do first, what do you do next, what do you do next. Finding the area, finding this capital B, the area of that little triangle. See, it might be that you need to take that little triangle and put it back out here with 5 and 3. You follow that? So that I know the area of that triangle is going to be 1/2 times 5 times 3. Sometimes when I put it all together to see the big picture, I've messed up the little piece that you need to work on to find the area of the base. Okay, number 19. A solid consists of a cone and a hemisphere. Well, I think I can draw a cone and a hemisphere. Let's try it. Here's the cone, and then the hemisphere sitting on top of it. It's like a snow cone.
That's a really cute cone.
If the radius of the common base is 2, so they just told me that this radius is 2, didn't they? And the volume of the cone equals what? Equals the volume of the hemisphere. Okay, what's the volume of the cone? Do you have a formula for the volume
The
of the cone?
volume of a cone is V equals 1/3 times pi times radius to the second times h.
Times what?
H.
Everybody have that down? See, the pi r, 1/3 pi r squared, well, I'm sorry, the pi r squared, that's the circle. Okay? And then the h, I better change colors here. The h is this height. Does it tell you what the height is?
That's what we're solving for.
No. So, I leave h in there. And what's r? 2. Right? So 2 squared is what?
4.
So the volume of the cone is 1/3 times 4 pi times h. Would that be the volume of the cone is 4/3 pi times h? That's the volume of the cone. Everybody agree? So now let's come up here and do the volume of the hemisphere. What's the volume of a sphere?
4/3 pi r cubed.
Everybody have that one down? You do now, don't you? You'll need to bring that with you. Okay, that's the volume of a sphere. So the hemisphere would be how much of that? Half of that. So what's half of this? Oh, that would just be 2/3 pi r cubed. Agreed? What's r? 2. What's 2 to the 3rd power? What?
8.
8. 2 times 2 times 2. So I have 2 times 8 is, so the volume of the hemisphere is 16 over 3 times pi. Everybody agree? And it said this equaled that, so this equals this. Well, if I take both
Okay.
sides, what?
Did you make it half? Like, cause we.
Okay, we did half.
Yeah, we did half.
Went
Oh,
from
okay.
4/3 to
We did.
2/3. Okay? So now, let's just clean this up. Let's take both sides times 3. Well, let's change colors. Let's take both sides times 3, and we get 4 pi h equals 16 pi. Everybody agree with that? Clear out those fractions. Then we want to find h, so we divide by 4 pi. Divide by 4 pi. And what does h equal?
4.
Ah! How cool is that? So you see what you do? You set up your two things that are equal, then you find out what they are, and then you solve for the h, the unknown. Oh, do you realize how much fun I'm having this morning? Helping you guys. I'm thinking you're going to have so much fun on Thursday working through that test. Aren't you?
So much fun. So excited.
Oh wait.
Okay, what's gonna mess with your head when you come to this problem?
Not those. Do we just?
It's too much work for one answer. If there's 20 questions on the test, it's only worth 5 points. Just forget it and miss it.
The ones that he skipped.
I mean, that is a lot of work,
It
isn't it?
says don't do the ones.
But isn't there some kind of satisfaction in your heart of hearts to doing all that work and finding that h is 4? You go, no, you're the only one in this room that gets a real buzz out of doing that. Okay, let's do the last problem. Here's where we stop with number 20.
I didn't understand.
A sphere and a cylinder have the same radius. Okay. So a sphere would be like a basketball.
Should I just tell you this? And go with
Okay? And a cylinder would be one of these things with this stuff dotted. Okay? So we've got a basketball and a cylinder. And the radius, is the radius 10 for both of them? Yes. And so the radius here is 10, and the radius here is 10. And what else does it say? The total surface area of the cylinder equals the surface area of the sphere. So the surface area of the sphere equals the surface area of the cylinder. See what we just said? See what they just told us?
And the surface area of the sphere.
So now what do I need to find? I need to find the surface area of the sphere. And what is that? What's the surface area of a sphere?
4 pi r squared.
Where'd you get that?
Too much fun. In the place in the book.
From the
From the
previous page?
Yeah.
Okay, so the surface area of this sphere, R is what? 10?
10.
So what's the surface area of the sphere?
400 pi.
400 pi. So the sphere is 400 pi. Everybody follow what I'm doing?
Mm-hmm.
Now I just need to find the surface area of the cylinder. That would be
It's
the
the same
top and the
thing.
bottom and around the outside, right?
But if the surface area of the sphere equals the surface area of the cylinder, can't we just find one?
But we're trying to find the height.
Oh.
What is the height of
but
the
we don't know this
cylinder?
height.
Oh, okay.
So that's this thing we don't know right here. Because we know the area of this circle, right? What's the area of a circle? Pi r squared. And what's r? 10. So this is 100 pi. Agreed? And this one is 100 pi. And what's this distance here, from here to here? Isn't that the circumference of the circle? Isn't that the top of this, when you cut this thing down and spread it out, isn't the top of this little rectangle the circumference of the circle? Is it? If I take this can and cut the top out of it and then cut down the side and spread it out, here's the top of it, and I spread this thing out, and it's like, hey, this distance here is the circumference of the circle.
Did we just find the surface area of the sphere? Or the.
Mm-hmm.
Yeah? Okay.
Okay,
So then
yeah,
how do we
up here
find the
was the
height
surface
then?
area of the sphere.
How do we
Okay.
find the height?
Okay, now how are we going to find its height? Well, do we know the circumference of the circle? Circumference is what? Pi times diameter. What's the diameter? If the radius is 10, what's the diameter?
20.
So the circumference is 20 pi. So that means this distance from here to here is what? 20 pi. So this area is going to be what? 20 pi times h. Agreed? So this little rectangle is 20 pi times h, plus this, plus this. So what I have is 400 pi equals 200 pi plus 20 pi times h. Everybody see that? See where I got those numbers? So now I come over here and go 400 pi equals 200 pi plus 20 pi times h, minus 200 pi, minus 200 pi, and 200 pi equals 20 pi times
This is a lot of
h.
pies.
Divide by 20 pi, divide by 20 pi, and h equals what? 10.
10. Not with a pi.
10 equals h. Wow.
Wow. Wow.
Ooh.
Now, did you know you can copy down what we have here and bring your notes from the practice test to take the exam? That just makes it too easy, doesn't it?
I have to go to work. I'm so sorry.
Yeah, it's time to get out of here, isn't it? And that's where we stopped, at 20. Well, see you on Thursday with a little exam.